Welcome back, Masters! You have already conquered the basics of generating patterns in our previous lesson. Now, it's time to take your skills to the next level. Prepare for an exciting adventure to the realm of numbers, patterns, and boundless opportunities. I am Riza Plabrica, your fellow Masters, here to share my knowledge in illustrating an arithmetic sequence. Let's dive in and ignite your passion for learning. Our objectives for today's lesson include enhancing your problem solving and critical thinking skills through hands-on exercises, defining, illustrating, and help you grasp the core to the concept of arithmetic sequence, and solving problem involving arithmetic sequence. As usual, the module that we're using for this topic is from Department of Education, Cordillera Administrative Region. Observe the following sequence. In number 1, sequence 4, 7, 10, 13, the sequence start with 4. To find the next number, add 3 to the previous one. So, 4 plus 3 equals 7. 7 plus 3 equals 10. And this pattern continues. 10 plus 3 equals 13. And so on. The common rule here is simply adding 3 to each term. Now, moving on to number 2. Negative 2, negative 6, negative 10, negative 14. This sequence begins with negative 2. To determine the next number, subtract 4 from the previous one. So, negative 2 plus negative 4 equals negative 6. Negative 6 plus negative 4 equals negative 10. And this pattern continues. Negative 10 plus negative 4 equals negative 14, and so on. The key rule in this sequence is subtracting 4 or adding negative 4 to each term. Finally, number 3. 1 half, 1, 1 and a half, 2. This sequence starts with 1 half. To calculate the next number, add 1 half to the previous one. So, 1 half plus 1 half equals 1. 1 plus 1 half equals 1 and a half. And this pattern continues. 1 and a half plus 1 half equals 2. And so forth. The constant rule here is simply adding 1 half to each term. Notice that to get the next term in each of the sequence above, a constant or a common number is added to the preceding term, or the number before it. The constant number being added is called the common difference, and we represent it as t. All these sequences are called arithmetic sequence. Okay, dear learners, prepare yourself for an electrifying lesson. Get your pens ready because we're about to embark on a journey of discovery with a new insightful example. Let's dive into the world of knowledge together. To determine if a sequence is arithmetic, we need to check if there's a consistent difference between consecutive terms. To do this, we calculate the difference between the second term, a sub 2, and the first term, a sub 1, which is 3 minus negative 4 equals 7. Next, we find the difference between the third term, a sub 3, and second term, a sub 2, which is 10 minus 3 equals 7. Then, we calculate the difference between the fourth term, a sub 4, and the third term, a sub 3, which is 17 minus 10 is equals to 7. Because there's a constant difference of 7 between each pair of consecutive terms, it confirms that the sequence is arithmetic. Now that we know it's an arithmetic sequence with a common difference of 7, we can find the next 3 terms. The fifth term, a sub 5, is found by adding 7 to the fourth term, a sub 4. a sub 5 equals a sub 4 plus 7 equals 17 plus 7 is equals to 24. The sixth term, a sub 6, is obtained by adding 7 to the fifth term, a sub 5. A sub 6 equals a sub 5 plus 7 equals 24 plus 7 equals 31. Finally, the seventh term, a sub 7, can be calculated by adding 7 to the sixth term, a sub 6. A sub 7 equals a sub 6 plus 7 equals 31 plus 7 is equals to 38. So, the common difference is 7, and the next three terms in the sequence are 24, 31, and 38. This is how we identify an arithmetic sequence and find its next term by adding the common difference to the last term. Hey there, learners! We are about to dive into the quick recap of our discussion. And if you have been following along and learning, get ready to put your skills to the test because we have got some fun questions coming your way. Question 1. Find the next three terms to the following arithmetic sequence: 3, 8, 13, 18. It's time to energize your mathematical brain and see if you can figure out what comes next. We have an arithmetic sequence. The first term, a sub 1, is 5. The common difference, t, is negative 2, which means each term decreases by 2. Now, let's find the first 5 terms. The first term, a sub 1, we already know it's 5. It's the starting point of our sequence. Now to the second term, a sub 2, to find the second term, we start with the first term, 5, and subtract the common difference, which is negative 2. So, 5 minus 2 equals 3. That's our second term. Now, in the third term, a sub 3, we take the second term, 3, and subtract the common difference, negative 2 again. So, 3 minus 2 equals 1. That's our third term. To find the fourth term, we use the same logic. We take the third term, 1, and subtract the common difference, negative 2. So, 1 minus 2 equals negative 1. That's our fourth term. Finally, for the fifth term, we start with the fourth term, negative 1, and subtract the common difference, negative 2, once more. So, negative 1 plus negative 2 equals negative 3. That's our fifth term. So, the first 5 terms of this arithmetic sequence are 5, 3, 1, negative 1, and negative 3. You can see how each term is found by adding or subtracting the common difference from the preceding term. It's like taking steps in a sequence, with each step being negative 2. Now at this juncture, let's embark on the mathematical adventure in another example. We are given two terms of an arithmetic sequence, a sub 2 equals 1 and a sub 5 equals 7. Our goal is to find the common difference t of the sequence. Recall the formula to find a term in an arithmetic sequence. To find the nth term, we add the common difference to the preceding term. For instance, a sub 3 equals a sub 2 plus d. Let's apply this formula to find the expression for a sub 4 and a sub 5. We have a sub 4 equals a sub 3 plus d and a sub 5 equals a sub 4 plus d. Now, let's substitute the expression for a sub 3 in terms of a sub 2 and d to the equation for a sub 4. we get a sub 4 equals a sub 2 plus d, which simplifies to a sub 4 equals a sub 2 plus 2d. Similarly, substitute the expression for a sub 4 in terms of a sub 2 and d into the equation for a sub 5. We get a sub 5 equals a sub 2 plus 2d plus d, which simplifies to a sub 5 equals a sub 2 plus 3d. Now substitute the given values a sub 2 equals 1 and a sub 5 equals 7 into the equation of a sub 5 equals a sub 2 plus 3d. We get 7 equals 1 plus 3d. Solve the equation for d, subtracting 1 from both sides. We have 6 equals 3d. Divide both sides of the equation 3 to isolate d. We find that d equals 2. Therefore, the common difference in the arithmetic sequence is 2. Before we dive into the other challenge, let's do a quick recap of what we have learned so far. In an arithmetic sequence, we have this magical number called the common difference. As like the secret sauce that makes this sequence work, we add this common difference to each term to get the next term. And it's what keeps sequence rolling. Now, let's put this knowledge to the test. Question 2. Find the common difference in an arithmetic sequence, where a sub 2 is equals to 18 and a sub 5 is 33. We are on a quest to find d, or difference. Now, before we wrap up, remember to hit that like button, subscribe to our channel, and ring that notification bell. We have got more exciting math adventure waiting for you in our next video. This has been your fellow master, Riza Flabrica. Until then, keep that mathematical enthusiasm burning bright. See you in next video and happy learning!